Yeah, so thank you, Peter, for the introduction. I'll just say that again. And it's a real pleasure to be asked to do this presentation to the club. Actually, it was 38 years ago that a VK3RV, old Mac McConnell, addressed the RAOTC at a dinner, a formal dinner, one of their early ones, where the ladies were all present apparently, and he spoke briefly about some of the early DC supplies in Melbourne. Well, I'm going to go a little bit deeper into it. In fact, I'm probably going to dig a bit too deep, so I've got to keep an eye on my watch because I could be talking for a while. And I will now just get myself into action. Right. Okay, so just before we get underway, and I will explain that I'm talking primarily about the power supplies in the inner Melbourne area, and in particular the Melbourne City Council area. We will touch a bit on some of those supplies that started in the early days in the outer parts of Melbourne as well. So, initially, a couple of disclaimers. Firstly, there's been no artificial intelligence involved in the preparation of the so all of the errors and oversights are mine. And I have to warn you, the brain box is slowing down despite what Peter said. Secondly, I did work for the Melbourne City Council Electric Supply Department many years ago, and mainly within the distribution and protection side of the operation. So I confess to being an interloper in aspects of power generation. However, recently I managed to obtain a couple of additional early Melbourne City Council reports, and together with some other research, it enabled me to sort of fit some parts of the jigsaw puzzle together. So, and it's been an interesting exercise. I won't say I've got it right yet. There have been a number of histories written about electricity, early electricity in Melbourne, and nearly all of them sort of conflict somewhere, but I think we're starting to piece it together a bit better. So I do hope you find this brief chronological meander through earlier times with its rapidly developing technologies both interesting and perhaps a little challenging. So, to start our journey, try to imagine not being able to flick a switch to turn on the lights, or to start a heater, or to turn on the air conditioning, or indeed to travel by electric tram or electric train, watch TV, or even play with radio, because that's the period we're talking about initially. Yep. So, before we get underway, a little background. Well before Victoria had the state government's Electricity Commission, Melbourne's electricity was supplied by private companies and local councils. Although not the first in the field, the Melbourne City Council was foremost in this new branch of applied science, and it helped develop it. And it was led by some pretty bright men, some of whom later became key personnel in the establishment of the Victorian State Electricity Commission. So this is also part of their story. Okay. Here's a very early transformer nameplate I recently came across. Note the comments here that this firm said they were specialists in the application of electricity to the service of mankind. Now, this is very interesting because I believe that this was also the philosophy of some of the key players in the early development of electricity in Melbourne and Victoria generally. So, a question. Where and for what purpose was electricity first used here? Does anybody have any idea? Come on, you all should know this.
Lighting, street lighting.
Yeah, but before that, before that. Okay.
Thank you, Thomas.
Electrocuting elephants.
No, electrocuting elephants. No, not quite. That was later, I think.
Nice candles.
The first commercial use of electricity in Victoria was for communications. Batteries were used. And here is a very early pre-Federation telegraph message sent and received by the then Victorian Telegraph Office. And some of you would have seen this in more recent times. Mike showed us this particular telegram. This is pre-Federation, so it's the Victorian Telegraph Office. This 1900 telegram was sent to a notable Victorian electrical engineer and wireless experimenter, Mr. Francis Chambers, by Walter Genby, who was operating a portable receiving station at Doncaster near the present shopping town. A few months later, in 1901, in May 1901, Genby made that notable contact with the Royal Navy escort ship HMS St George, accompanying the Prince of Wales to the Federation celebrations in Melbourne. So in this telegram, we have a report to Chambers by Genby. It provided the date, the time, the location, the names of those involved, no call signs in those days, and a signal report and a comment on the equipment and condition. So therefore, I believe this is our first QSL in Australia. And it's a bit more than your 5 by 9, mate. But we digress. Two ways. Number one, for many years there's been a discussion about when did the Wireless Institute of Australia start. There was a lot of sort of confusion going on between Sydney and Melbourne, 1910. I'm starting to believe more firmly, and Chris Long, who was here with us today, pointed some of this out to me some years ago, that the confusion possibly revolved around a club or an organisation within the Post Office, the Telegraph Society, which Chambers was a member of, and Genby was a member of. Chambers, in fact, is perhaps our first bright spark in this conversation here today. He was also involved with the first electricity supply in Melbourne in 1880, when he was involved with the Victorian Electric Company, and Chambers later became the Post Office's chief engineer, electrical engineer. So, returning to the chronology, as mentioned, distributed electricity started well before the State Electricity Commission, in fact about 40 years. And initially it was used solely for street lighting, as somebody mentioned up the back here, and especially for public, what became known as public lighting. A growing essential service in a city which was expanding. A little local history. Melbourne was first settled by the Europeans in 1835. The city's street grid, attributed to Robert Hoddle, 1837, and we'll come back to that. There were about 4,000 odd buildings by 1853. 1854 saw not only that first telegraph, but also the first steam railway. Telegraph systems sort of go hand in hand with railways. Absolutely essential. So that was a key event. And during 1869 there was a submarine cable connected to Tasmania to stop it from drifting away from us, I think. Okay, this is the oldest map of Melbourne I could find. You'll note that there are no street names, just a grid. The site of the future power station is there. This is an interesting bit, Batman's Hill, right there. Now you won't be able to read this, but you can probably see some penciled remarks there on the original drawing. And it says reserved for future botanical garden. What happened to the botanical garden? Well, the railways bulldozed the hill because they were into the game earlier than a few other people. And of course that became their the site for their administrative office and Spencer Street Station. Also note where Russell selected a spot for his take-up, and that was right at the falls, the old falls, fresh water above the falls, tidal water below. Pretty smart man, Mr. Russell, and I think he really should be given a bit more recognition, because, as I've got here, he reportedly did the layout of Melbourne in his spare time. Okay, so what makes up the city of Melbourne? Well, that's the city of Melbourne, the CBD in the middle, and areas such as sort of part of the St Kilda Road area, Carlton, Parkville, Flemington, and most of the docklands. Our first significant street lighting involved lighting up the dark ways of Queen Street. Well, that's how the newspapers reported it. Melbourne City Councillor Smith seems to have paid personally for the first multi-gas lamp street lighting installation along part of Queen Street in the vicinity of his Queen's Theatre, and that was during 1847. Celebrations often trigger exhibitionism. Taradale in central Victoria, up near Woodend, celebrated an overseas wedding by planting 2 oak trees and holding a sumptuous repast together with free drinks. They know how to celebrate in the country. In Melbourne, amongst other things, we celebrated with 3 arc lamps, floodlighting the Victorian GPO in Elizabeth Street, the Telegraph Office and Parliament House. So here we have perhaps the first use of electricity for public lighting in Melbourne, albeit powered by batteries and a temporary installation only. But I believe it was dramatic. The intensity of those lights was something that the person had not seen before, unless they looked at the sun, I guess. But where on earth did all those batteries come from? The answer can only have been the Victorian Telegraph Office. Street lighting trials were conducted in many cities, such as this one in London during 1881, and experiments were sort of conducted to sort of find the best way to use arc lights. They experimented with lamp types, intensities, heights, and locations, reflectors and all that sort of thing. Now, a couple of years earlier, however, during 1878 to 1879, Sands and McDougall's, the printers, and the Apollo Candle Company imported and installed arc lighting plants for their buildings, and these were probably the first organisations to regularly use electricity for lighting in Melbourne. London and New York established electric street lighting in 1882, and both of those cities used the Edison system. Melbourne likewise initially used DC, and in many ways was up with the rest of the world at that particular time. Now this timeline shows most of the early power suppliers in the Melbourne area, and you can see that the first one here is 1880, when an attempt was made to establish a commercial undertaking, when the Victorian Electric Company was given permission by the City Council as an experiment to light the rebuilt Eastern Market. That's up on the corner of Burke, or was on the corner of Burke and Exhibition Streets, where the Beatles arrived, you might remember. Television footage. No? Yeah, a bit of mumbling going on amongst a couple of oldies down here. Anyway, they installed 6 arc lights and a portable generator, and Chambers, as I mentioned earlier, was involved with that particular company. The council was impressed, and in March 1881 entered into a contract with the company to continue the experiment, but with an option to purchase the generating equipment. Yeah. Now, city councillors have always been smooth operators. The council was becoming interested in electric lighting. Now, the renamed Victorian Electric Company established a power station in Russell Place, which is just behind the town hall off Little Collins Street, and in late 1881 supplied electricity for lighting the Athenaeum Theatre, which was the first Mechanics Institute in Victoria, and I think Australia, no, Tasmania might have been in Collins Street, and the Melbourne Opera House, which is later known as the Tivoli in Bourke Street. So the council went on to contract a number of private undertakings, and here you can see this one changing into the Australian Electric Company and then combining with another organisation, a shortly lived organisation, the Australian Electric Light, Power and Storage Company, and that became the new Australian Electric Company. It's all very confusing unless you know exactly which years these name changes took place. But unexpected things do happen, and in 1890 the gas company was forced to ration gas supplies because of a maritime strike, and lighting methods in the city came to a bit of a head. Consequently, the Union Electric Company was paid to install a further 15 arc lamps at city intersections, making the total about 60. The die had been cast, and in March 1891 the first city electrical engineer, Mr. A.J. Arnott, previously of the Union Electric Company, surprise, was appointed to design and construct an electricity, lighting and power station within the city. However, the possibility of electrically derived motive power attracted the attention of the Melbourne Hydraulic Power Company, which was established in 1887. It naturally assumed that it had the monopoly of distributed mechanical mechanical energy in the city, and legally pursued the matter in 1899. And if time permits, we'll come back to that a little later. Back to electricity. Initially, anybody could start an electric supply business. Besides having the capital to purchase the generating equipment, the poles, the wires, etc., the only agreement you needed was the approval of the local council to install those poles and wires. But that all changed in 1896 when the state government proclaimed the Electric Light and Power Act. Consequently, regulation and control of electricity in Victoria commenced. Now let's pause at this point and have a look at the start of the council's Electric Light Power Station in 1894. The design of the station, as I mentioned, commenced in about 1891, and it was officially opened in March 1894. Now that's not a bad effort. They had to build the building, they had to order the equipment from overseas and install it and get it all up and running. So here are the 4 original boilers, each of which could produce steam at the rate of about 7,000 pounds per hour. You're all oldies, you know what pounds are. 7,000 pounds per hour at about 150 psi pressure. As a comparison, in 1953, a much later boiler was installed at Spencer Street, an oil burning boiler, and it could produce 300,000 pounds per hour at 600 psi. 43 times the steam output at 4 times the pressure. Note the coat of arms on the doors of the boilers here. The council was well proud. And here are the 4 single-cylinder 300 horsepower horizontal piston Australotus steam engines and their 14-foot diameter flywheels. They weighed 10 tonnes each. Initially, each engine drove 5 arc dynamos or generators, and that was a total of 20. There were 15 outgoing circuits from the power station, which meant that one unit, a complete engine and dynamo, was held in emergency reserve. This is a wider angle view of the of the station with the counter shaft running along the middle here. You can see the flywheels for 3 of the engines here, the 4th one's in this spot. You can see that these are driving dynamos. Each one drove across onto 2 dynamos which are circled there, and the other dynamos are disappearing into the background behind it. As a matter of interest, this is a drawing of the Doncaster electric tramway dynamo. It's very similar to construction of these, probably not quite as large, and that was 1899. And that tramway system ran up to the Doncaster shopping town, which is where Genby had his receiving station in 1900. We're getting sidetracked again. And note the airborne arrow here, that is pointing out where the switchboard is. And there's the switchboard again with its wonderful coat of arms on the top. Council was really getting excited with themselves here, and it was quite an ornate looking thing. There was a council report which said that the generators and 15 outgoing series lighting circuits were controlled by a very ornate switchboard which could only be likened to a high tension telephone exchange. So much for the reporters. All distribution at that time used 1/4 inch diameter overhead copper wire at 3000 volts, and each circuit fed up to 50 arc lamps. Now, this is a typical arc rod, not an original, unfortunately, but they would have 2 of those, one facing each other in the arc lamps, and they would be automatically fed throughout the night. I'll just pass it around if you'd like to. No prizes for breaking it. Being a constant current series circuit, each lamp produced the same candle power, and if one happened to fail in that series circuit, it had an internal shorting system, whether it be the arc lamp or whether it be an incandescent lamp, an early incandescent lamp. It would short out and complete the circuit and keep the rest of the lights on in that particular circuit. Now, this was all overhead stuff, but by 1900 it was decided to underground the unsightly overhead wires, particularly within the CBD. And this was accomplished within 3 years with the help of returned Ballarat miners. They were good at digging holes. Now, what about AC? I might hear you ask. Yes. Well, the first successful Westinghouse, or should it be Tesla or Stanley, AC commenced in 1886. But the 1891 Gold King mine at Telluride in the USA was a very successful 100 horsepower, 3000 volt hydroelectric system, and it is considered by most people to be the first notable AC installation. In some place called Melbourne, at about the same time, a character who called himself the city electrical engineer started to plan a power station, an electric lighting power station, and a distribution system. Here's the important point. He decided to add 1 spare position on each of the 300 horsepower engine countershafts for a future alternator. Mr. Arnott was obviously following developments in electricity very closely, and Melbourne was the beneficiary. We were up with the rest of the world. So, less than a year after Spencer Street was opened, orders had been placed with the General Electric Company for 4 75 kilowatt 2000 volt single phase alternators to improve mainly the lighting in the more remote areas of Melbourne, because the DC really could only be distributed over a mile or 2 before it started to lose too much power in the resistive losses in the cables. AC was considered by Mr. Arnott to be the answer to this, and He ordered these alternators and they went into service in 1896. Also ordered from GE were 130 transformers with capacities from 3/4 of a kilowatt to 12 kilowatts. The generation frequency was apparently not considered important at all, and it later transpired to be 72 cycles. The 2000 volt feeders were also used to supply private consumers with lighting within their houses at about 100 volts. And somewhere here, this is just a little bit later, and you all might have seen pictures of ironing, people ironing clothes with a plug stuck into the light socket in the kitchen. Well, this is one of those plugs, but also this particular one is a socket. And here is the mating plug, which you would plug into that, so you could have a choice of using the iron or maybe plugging in a separate table light or something in that order. So that's from those days, and the voltage which they were running, the secondary voltage was 100 volts. So that was our first AC mains voltage in Melbourne, 100 volts. Okay, moving on. The Government's Electric Light and Power Act of 1896 gave the council a right to acquire properties and customers of the 3 private undertakings operating within the municipality, which they did. So at the end of the 19th century, the council's electric supply department was becoming a significant electricity generation and distribution organisation, and again I will say of world standard. Finally, over 100 councils had similar organisations, and for example, they obtained these orders in council, and you can see here number 1 was to a private company who set up at, they were one of the original early stations. They set up a plant at Burnley and Richmond area anyway, and also another private organisation which was the remains of the companies which were operating in the city area. Melbourne City Council, Ordering Council number 3, and the other private company in Melbourne was Drapers or the Union Electric Company. Interesting to see that the first regional ordering council went to the nil electric supply, which is a bit surprising. What happened to Geelong and Bendigo and Ballarat? Well, they weren't far behind, but nil for some reason was in there. So Williamstown, as a matter of interest, was issued with Ordering Council 111 in 1915. Okay, so this is the Spencer Street Power Station in 1901 with an arc light up here, typical street arc light, and a pole with heaps of radiating wires, because in 1901 there was still a lot of series DC lighting circuits around. Commercial directors around 1895 referred to the power station as the City of Melbourne Light Station, but by 1909 listings had it as the Electric Power Station. So it was now being used more for lighting, for things other than lighting, I should say. And you could phone them on Central 153. In time, some of the private power supply premises became important substation sites for the rapidly growing city power load. How are we going for time? Goodness. On the other hand, smaller towns, smaller communities had less grand power supplies, and indeed engineers' residences. Nothing like Melbourne. So we just go back to this one slide here. This was the engineers' residence here. That was the engine room, and these were offices. And the boilers were located out the back here. This is where all the carts of coal went through. So in Sunbury's case, a much more basic installation. And during 1926, the Bullitt Shire Council at Ransunbury asked the newly established SEC to take over the responsibility of power supply in Sunbury. They'd had enough. They wanted out. Nearby Gisborne's initial power requirements were less than Sunbury's. However, it was all a bit touch and go in Gisborne, as any additional load could easily cause an overload condition and black out the towns. And things were so tight in Gisborne during 1924 that, according to the station's engineer, Tuesday night was the only night that the generating plant had enough spare capacity to meet the additional power requirements for a silent moving picture show with its single carbon arc projector. Now, returning to Melbourne, you won't be able to read this at the back of the wall, so I'll flip through it pretty quickly. But this shows on the left of the line what was happening in the Melbourne City Council area over the years from the time that the power station started in 1894 through to about 1930. On the right, we have what was happening in the suburbs. And the suburbs in those days were being fed entirely from the organisation that became the Electric Light and Traction Company, and then later the Melbourne Electric Supply. It's actually interesting, this company really stirred the pot quite a bit, because it turned out that it was really an English company, an offshoot of the Brush Company, and that sort of set a bit of concern through people up in Parliament House, or down in Parliament House in those days, I guess. Anyway, it was actually one of the triggers for the Melbourne City Council being allowed to grow to the size that it did. And at one stage there was even talk of the whole of the power generation for the Melbourne and municipal areas being done out of Spencer Street. But of course that could not happen with the load which finally evolved. But up to into this period of time it was quite possible. Anyway, this organisation later became known as Melbourne Electric Supply, MES, and many of you will have seen those letters on various fuse boxes and things around the place. There are various voltages, I won't go through it all, but the council started using three-phase 50 Hz around about 1913. What else can I tell you? I'll point out here, this is an interesting thing. The powerhouse was starting to get fairly heavily loaded and they were looking for alternate supplies. The railways had built a power station at Newport, and they didn't have enough trains to soak up all the power, so an agreement was reached. The only problem was the railways were generating at 25 Hz and the council had gone over to 50 Hz. So they had to put in a frequency changer which didn't come online until 1921. By then the SEC had also got a powerhouse going at Newport, and you can see that bulk supply to Melbourne started taking place around this time here. There was a bit coming in here in 22, I think it was. So enough of that. The remains of the three private companies are those that are listed up there: Heffernan Lane Substation, Russell Place Substation, and Coors Lane. From about 1906, the only electricity undertakings in the Melbourne and metropolitan area were the council, the Melbourne Electric Supply in Richmond, and another company which started in 1905, I think, the North Melbourne Tramways and Lighting Company, and they were located in Ascot Vale. So, our time travel now takes us to a very interesting time of distributed power in Victoria, and involves a largely forgotten brilliant engineer and thinker, H.R. Harper, Melbourne's second city electrical engineer from 1901 to 1919. And many twists and turns in electrical power generation and distribution took place in Melbourne and later Victoria under his watch. And for the amateurs amongst us, and most of us are, He was the grandfather by marriage of Jim Kirko, VK3KA, who happens to be a member of our Macedon Rangers Club, and that was very interesting to learn that because I managed to get a bit more information from the family. Anyway, Herbert Rea Harper, 1871 to 1956, often referred to as HRH. I wonder why. I think he got his own way often. Was born in London and educated there. In 1893 he joined the Brush Electrical Engineering Company. That's the crowd that started up what became MES, where he gained experience in power generation, town lighting and tramway systems, all being municipal activities at that time. Now, Brush sent Harper to Melbourne to work at the Electric Light and Traction Company in Richmond, and set up, we're on the right one, and he set about updating the growing Melbourne council system, including improvements to supply in areas more remote from the power station. The overhead single-phase transmission voltage was raised from the 2000 volts to 4.4 kV AC for the feeders to the transformer substations in the outer areas. And in 1911, Harper went to Europe and America to study electrical developments. While he was in Germany, he witnessed the use of brown coal, and on return conducted a series of brown coal tests at Spencer Street Power Station. Further major system changes were made, and between 1913 and 14, three 6.6 kV three-phase turbo alternators were installed at Spencer Street. Turbo alternators. Harper went on to replace the direct DC generation at Spencer Street with large rotary converters installed closer to the central city power points or power load, and these were fed with 6.6 kV three-phase AC from Spencer Street. This was a major change which greatly reduced the I2R losses and made the whole of the system, the DC system, far more efficient. In 1934 he was awarded the Melbourne University's Curnow Memorial Medal for Distinguished Engineering Achievement in Australia, the Curnow Medal. Professor Curnow was one of the directors of the original Victorian Electric Company. So you can start to see a bit of a pattern here. There were people who were involved in early electricity, that were involved in early radio, that were really sort of setting the pace. And most of these people we have not heard about. But they are there, and if you dig deep enough you will find things like the Curnow Medal did exist. I think it still does actually. Anyway, moving on. The load on the power station was continually growing dramatically as electricity became a truly essential service. Hospitals, lifts, multi-storey buildings, all that sort of thing. Harper was a fervent believer that industrial prosperity would migrate to those places where the cheapest electric power was available. And he strongly made this point at an inquiry into electricity supply in 1918, a point which the state government later took up. He was also continually seeking and adopting the most efficient and up-to-date techniques for power generation and distribution. So, in many ways, HRH was a major trigger for the establishment of the Electricity Commission between 1918 and 1919, which itself resulted in the State Electricity Commission in 1921, of which he became its first chief engineer. So was he really planning this from way back? But when he left the council, he took with him a chemist from the council's power station, a high voltage operations engineer and a draftsman. So he had some key people there when he helped set up your lawn. And all these people became, or these three people besides Harper became key men in your lawn. Glancing back a few years, in 1907 and 8, these 750 kilowatt 4.4 kV single phase turbo alternators were the ones which were installed to replace the remaining of the DC lighting plant, and you can still just see one of the lighting, part of the main countershaft there, and one of the flywheels in service and generators, so that some was still there at the time this photo was taken. And here's another digression. The minutes of the Wireless Institute of Victoria for March 1913 recorded that, quote, an inspection of the Melbourne City Council electric powerhouse was arranged for March the 12th. Why? Well, the look at a power station was obvious, but perhaps getting close to any large rotating alternator in 1913 was something worth doing. There weren't too many of them around, and radio amateurs would have heard about high frequency rotating RF alternators used overseas for long distance communications. Many Alexanderson type transmitters, such as this 200 kilowatt US naval station, were in service during World War I. And some were still being installed as late as 1922, with power levels of up to 500 kilowatts at 15 kilohertz. Then HF stepped in and became the long-range wireless communications medium. But in 1913, when Harper commissioned that first three-phase turbo alternator, a 2.5 megawatt machine, 2,500 kilowatts, replacing, it was being used of course to replace that old single-phase stuff. And I think this was what the highlight of that WIA members' visit was all about. To see a quite large multi-phase, and it was in fact a Bella Siemens turbo alternator. Back to our main topic. It was 2 years earlier, in 1911, that the last DC generator was installed at Spencer Street. From this time on, alternating current and rotary converters took up the load. The largest rotaries were installed in Melbourne at Russell Place and Tavistock Place. They were 2.5 megawatt machines. Heffernan Lane in Chinatown, which was the old Union Company's power station site, was chosen to become the initial rotary substation, and the first of 4 1.5 megawatt rotary converters were installed there in 1915. And here's another interesting sideline. A few years earlier, a Siemens 4,000 ampere hour capacity accumulator battery was installed at Heffernan Lane, presumably for use as some form of limited standby facility if Spencer Street, or indeed the rotary converter that was planned to be installed at Heffernan Lane, failed. But more than likely it was really to smooth out those peak, short-term peaks of power demand on the power station itself. Now the rotaries provided a purer DC than the original dynamos, which were unidirectional pulses more than direct DC. But they made a lot more acoustic and electrical noise. They got into the telephone systems too, I believe. And they required a full-time attendant to keep an eye on them, keep an eye on the brushes and to oil the bearings, etc. But they were gradually installed across the whole of the CBD, and that map there sort of shows some of the places where they were installed. And also a few were installed at the power station. Little Queen Street became a major city rotary substation with an installed capacity of about 12 megawatts. And here's something which a lot of people probably would not have thought about. Picture theatres really needed an AC supply for accurate speed control of their new talkie projectors. And city theatres installed small motor generator sets from the start of sound films in 1929. Although the supply to the Regent was direct AC. And the Regent also fed power across the road to the Athenaeum, the substation, the AC substation of the Regent, and I've often wondered whether the Regent people knew that they were supplying AC power to the opposition on the other side of Collins Street. Probably not. Anyway, the peak load in DC occurred around 1930, and at that time there was about nearly 44 megawatts of installed capacity in Melbourne. As the high voltage AC system expanded, so the need to keep the system diagrams up to date. And this one is from 1917, during World War I. Before the SEC, the council bulk supplied AC power to other municipalities, including Footscray, Port Melbourne, Brunswick, Williamstown, Coburg, as well as the Brunswick-Coburg trams. And another customer, not mentioned on this diagram, for obvious reasons, being World War I, was the Defence Department, in particular the Corday factory out near Melbourne. So the Melbourne bit is something I've added on there, but it was obviously fed from that circuit. Let's just take a quick look at an inner city bulk supply substation. And this is Russell Place we're talking about. It was the site of the 1882 DC power station of the Australian Electric Company, previously the Victorian Electric Company. It became a DC rotary substation in 1929, and it was reconstructed as an underground import substation in 1947, where 22,000 volts cables came into the building by the SEC. They were transformed to 6.6 kV, and the council purchased power at this point. And this building was also the last source of MCC distributed DC. So very quickly, that's what the main access hallway looked like. It's underground. You're a good 2 stories underground. It was also a zone substation or area substation supplying 400 volt power in the general area. Let's have a quick look at what that involved. That's a 6.6 thousand volt paper insulated lead sheath cable coming into the terminal box of the transformer, which I think is a 2 MVA transformer, the output of which is fed through those isolating links and an air circuit breaker onto the bus bar, which in turn feeds red, white and blue phases of the 3-phase circuits heading out of the building. On the right here is a public lighting panel, as it was called. That's a street lighting panel, relay controlled from the distribution radio control centre. The SEC imported power at 22 kV and passed it through 3 of these 10 MVA transformers and fed the council with the 6.6 kV. There were heat exchangers and cooling fans and all that sort of stuff. They were located in another compartment because underground substations get very hot. There's nowhere to get rid of the heat if you're not careful. This is a 6.6 kV part of a switch room, and here you can see this particular high voltage switch, which is a metal clad oil filled circuit breaker. Metal clad meaning that the bus bar system, instead of being open as in the previous photo you saw at 400 volts, is actually in a chamber running along the back of the switchgear. This particular one is on, and it is feeding Russell Place number 5, which was that transformer in the zone substation. This one is on as well, but we've successfully obscured the nameplate. And these 2 are actually off, and you can see that they're further back towards you because they are racked out. They're not racked into the bus bar. And that's because there's obviously some work going on the feeders or the equipment itself. And so they're positively disconnected from the high voltage bus. This is just a 6.6 kV feeder control and protection panel. This was taken at a weekend on one of the inspection days they had down there, and there's very little load. You can see these are peak reading ammeters, very little load on these circuits, although I suspect that one's out of service, and maybe that one. You can see they've got temporary to stick on labels have been put there. Maybe they're doing maintenance work on part of it. This one actually snuck up a bit overnight, I'd say, with power, whatever that was feeding. And a last look at DC. This is how the last of the Central Business District DC load was supplied by mercury vapour rectifiers. It's a bit of a blurry picture, I'm sorry about that. And these were used to replace the rotary converters from about 1955. The reticulated DC supply in the city was terminated in 2003, just over 100 years from when it was established. And a very last look, you've all seen these pillars on the corners of streets. They were the original cast iron DC cubicles where customers or street lights could be fed from. Finally, they ended up by being used and are used today for street lighting and other facilities such as supply for traffic signals, pedestrian lights, crossing lights, etc. That's a Sydney one, and this is a done-up Melbourne one with some of the original wooden news carriers. Just very quickly, how are we going? Oh dear. How are we going? Good. Got another few minutes? You're still all interested or are you asleep? Okay, well I'll burn on through as quickly as I can. A quick look at the power station itself. This is the 1901 picture. Note the arc lights and the feeders, as I mentioned before. This is a much later photograph taken around about 2004, just before demolition took place. The red brick building, I think, is still there, and this is the 1950s extension for the powerhouse. This area here was known as Substation J, high voltage Substation J, and it was also the point of bulk supply for this part of the city from the SEC to the council. Now, this is a floor plan, and I have a copy here. I'll pass that around too to some of you who might want to read something in particular there. A bit hard to see, but quickly, that's Substation J, that's the red brick building. This is the new extension here. These are all alternators of various types, and this is the control room. Substation J has been replaced by a new sub known as Substation JA. Keep this more or less the same name running. And that was built in 1965 and it's still in service. A couple of interesting little things which will come up. Cooling water via an under road tunnel, 7-foot diameter tunnel up King Street into the powerhouse. That was installed in 1941. There's another supply shown coming in here, which was the old original water supply that came up under King Street from I think it was about a 600mm, 2-foot diameter pipe. The installed capacity at the time of this floor plan was about 86 megawatts, and in 1959 they installed another 30 megawatts. All of the power generated was under the control of the SEC, and the council had to buy back power that its own station generated, but that was part of the original 1941 agreement with the SEC. The SEC, I mean, we're all starting to learn about problems of trying to connect lots of power generators together into a circuit. They had it back in those days too. There had to be one controller that was the reference point to keep everything synced properly. And of course the wonderful story about the SEC at midnight correcting all the clocks in Melbourne by speeding up the alternators to pick up the lost seconds through the day due to increased load and frequencies changing. Back again to this. Note that arrow there. We're looking at taking a photograph. We're looking at a photograph next that's taken from that view of. Okay, so here we are. There's that large last 30 megawatt alternator. That was the last one that was installed before at the time of that floor plan, and also at that time in 53 a 15 megawatt, and here's an earlier one that went in, the 15 megawatt machine. In see here, those two were running at the same pressure, but we're starting to sneak up in pressure here with the later machines. These are all turbo alternators. So staffing, operation and maintenance of the council's power station remained the council's responsibility. But in 1980, in December 1980, in fact, the SEC advised the council that power from Spencer Street was no longer required. And demolition of the station, generating station, commenced in January the following year. But part of that station was mothballed and in many ways just forgotten about. And here, I'll get to it, here we are. Here we have a photograph of part of it that was mothballed. The control centre. Note the date of the photograph. By 2007, the site was substantially cleared of unwanted buildings and the landmark Lonsdale Street power station chimney demolished in 2008. So ended a remarkable era in Melbourne's engineering and social history lasting over 100 years. Oh, I should just also add, sorry, now I really lost it. This photograph was taken during a dispute in 1977, SEC dispute. When you've got a city like Melbourne running, you can't just turn all the power off despite how aggravated everybody could be at the time. You're down in Gippsland. You had to keep those hospitals running, you had to keep lifts available in multi-storey buildings. So the answer in those days was, well, the union at the Melbourne City Council is a different union to the union in Gippsland, so we'll get the council to run its power station, and in fact that's what happened. The whole power station did in fact become a peak loading station and was used for emergencies on multiple occasions. But it was a sweet arrangement. It had to be. You just can't turn things off and turn them back on again. Loose ends. Radio comms. In June 1944, during World War II, a radio system for the one-way transmission of operating instructions to a limited number of vehicles was commissioned. A 250-watt transmitter operating on about 2.836 megahertz was located at the Waratah Place substation. There's that Waratah Place, Heffernan Lane area. Waratah Place is adjacent to Heffernan Lane. A key area in Melbourne. The radio system operated one way only, so it was effectively a broadcast, and any response that was necessary had to be made by telephone. AWA manufactured and installed the original base station, which fed a quarter-wave vertical on the roof of the substation there, and modified car radios, being crystal locked of course, you couldn't have people tuning off onto one of the broadcast stations at the time, were used in the vehicles. But by December 1947, a handful of vehicles were fitted with 75 megahertz VHF transmitters, enabling a reply to be made to the control room. And it does appear that these initial installations were made by Electronic Industries, and that was discovered simply by enlarging that photograph, and that nameplate has Electronic Industries' name on it, so interesting. The medium frequency station transmissions were heard in New Zealand, and here's an SWL report received by the council, including a slight frequency discrepancy. The AM transmitter was still operating in mid-1955, we know that, but the exact date of closure is not known, probably within 6 months of that date. And the Electric Supplies Social Club established an amateur radio club, which constructed a station during the 1930s in Heffernan Lane, before VL3GA, before the council station. And this is a QSL card that I found in the Institute's archive. Not sure when the club folded. It would have closed down, of course, during World War II and probably never restarted. But then again, the thought of sharing the site with VL3GA after the war with a TRF receiver would have been a distinct challenge. And finally, the hydraulic power. It was established in 1887 to supply high pressure into the CBD for lifts and presses. It may be that the first passenger lift was actually in the Clerk's mansion in Sunbury, but that's another story. By 1899, the Hydraulic Power Company was very concerned about the announcement that the council was proposing to sell electricity for motive purposes. Now, you can see they put in quite an investment. It was basically 6-inch cast iron pipes with each thick walls, 25mm walls. Their main pumping station was near the railways yard in the Flinders Street extension. And later a second pumping station was established up near the RMIT in Knox Place, and it was used for compressing wool bales. January 1925, according to the order in council, the assets had to be handed over to the Melbourne City Council. That was part of the agreement which was made by the then owners and the government. And at that time, there were 168 passenger lifts, 428 wood lifts and 42 hydraulic presses. Hydraulic presses for compressing bales of hay and wool. Anyway, coming back to the concern over electric motors, the Hydraulic Power Company's directors strenuously opposed the council's proposition. It went to court because in their view, competition by the corporation of the City of Melbourne would be exceedingly unfair. Thankfully, they were unsuccessful in having electric motors banned in Melbourne. Under the original Act of Parliament, as I said, the system went over to the council. The council installed electric pumps. Thompson of Castlemaine made the actual pumps, and they had a couple of 375 horsepower motors driving them at Spencer Street, all rather ironical. Just looking again briefly at the floor plan, that's where the accumulators were. You can see here there are a couple of hydraulic pumps to pump water up into the accumulators. Yarra River water from Dights Falls was fed through a 10-inch wooden pipe through Collingwood to the fish market, the old fish market site, where it was joined to the old cast iron pipe which was installed there at the time of the first power station. 2-foot diameter pipe was spliced on there, and that pipe ran up under Spencer Street to the station. Now, one accumulator was weighted to 100 tonnes to provide about 800 psi or 5,500 kPa nominal pressure, and the other weighted to 90 tonnes to provide a reduced pressure for off-peak periods. And the electric supply was given the job of looking after it until it was closed down at the end of, when do you think?
Late
Any
60s?
guesses? No?
Pretty recently.
Sorry?
I'm guessing 1970 something?
Yeah, about 1967. And I can remember seeing those accumulators going up and down. So you were both close, but...
Late 60s.
Yeah, late 60s. Yep.
There was a passenger lift in the former Guests Biscuit
Yeah.
factory diagonally opposite ABC Broadcast House.
Yep.
That used to be a pest of a thing. Steve, 3HK.
Hello.
Did you remember the hydraulic passenger lift in the RA building opposite Broadcast House?
I can't remember that one. I remember one back at the SEC in Little Lobster.
Yeah, I've just lost the name of the building now. There was, and the frontage of that building is still there in Collins Street.
Yes.
Yep. That I can remember riding in that lift in the 60s. Anyway, righto. So, unlike, well, this is what they look like. A couple of vertical poles with a big cylinder that went up and down as the system was used. There were two of them side by side. But unlike the invisible high pressure water pipes in Melbourne, which you can't see, you can still see these. And these are pit covers for the shut-off valves. And these two are in Rutledge Lane off Hosier Lane, which is the lane up the side of the forum, where all the tourists come to look at the, I'm not allowed to say graffiti, modern art on the walls of buildings. There are truckloads of them that come in every day. Sorry.
You were right the first time.
Oh, right, thank you. This one is obviously, I'd say, from the days pre-1925 when the council took over. It's a power department, whereas this one, and they're almost side by side, I might add, is the hydraulic power company. So, and I believe there are a few others around. If you have a look around the Grave Street, you look for cobblestone laneways if you go looking for these things there. Many of these lanes have just poured bitumen over the top of everything so you can't see. Well, at long last that brings us to the end of this presentation. I hope it's given you a bit of an insight to not only the electric supply but other aspects, all largely lost nowadays. States of the art, you know, in engineering activities in those days within Melbourne and the surrounding areas. And to finish off, there's a giggle for you. Times have changed. Thank you.
Do we have any questions? Yes, David.
I gather most of this power generation equipment was engineered and manufactured here in Melbourne
Some
or
of it was.
Victoria.
Yeah, the boilers were Babcock Wilcox, the Austral Otis gear was made here. That's the original stuff. But later on, of course, English Electric, General Electric, they were importing the alternators from overseas. That's my understanding. Yeah.
That radio system that you described, does that predate a similar system that the MFB used?
No, I think MFB was well ahead. I think, look, if you look at the date, it was late 47, mid 47, and things were getting a bit touchy. You know, there's this Brisbane line and all that sort of stuff being talked about, and with Japanese planes have been flying around Bass Strait. And I think that somebody decided, well, if it's going to happen, we've got to be able to control the network somehow in the city. We're going to need hospitals, we've got to keep power on in certain areas. So I think that's when the decision was made.
And it petered out towards the late 50s.
Yep.
So the MFB one continued much later into about 1970.
That's right, yeah. Sunday morning was a good one, good time for listening to the police one. When I was a kid, I can remember that. Wake up and hear all the calls in from just above the broadcast band as well. Do you remember that one?
I don't remember that.
Yeah, oh gee, I'm older than you.
I did listen to 3UZ's
Yeah,
Newsweek program.
Yeah.
Steve HK.
Yes, I seem to recall, at least in the 60s and 70s, Box Hill and maybe Coburg were supplying power. Did they have their own generating system?
Some of them did initially, very initially, a bit like Sunbury. They had a very basic DC station. I don't know, I can't answer that specifically, but they had to get an order in council to sell power in their municipalities anyway. I don't believe Footscray ever had a power station, and yet I know for sure, because of family connections, that their power was coming from Melbourne, and some of the documentation verifies that. Those councils, though, later became, and Northcote's another one, later became suppliers. They received bulk power from the SEC, probably at 6.6 kV, and had their own maybe 3 or 4 substations, and broke it down and then had toll subs around the neighbourhood. That's my understanding.
Now with the Tassie link, were we giving them power or get power from them?
Both, I believe.
And what about the attenuation of power loss? Was there any sort of amplification so that we get the right amount of power?
Yeah, it's called a transformer.
I'm thinking of the transformers in the
No, not on the Tassie link, that's DC. Yeah. But on the long, you know, if you think about what I mentioned with the outer areas in Melbourne, when they went from DC to early AC,
Yeah.
they put in transformers there at AC and they had taps on the transformers. As the load went up and the volts went down, they could alter the tap on the transformer, and that happens still today. You will notice sometimes your lights just give a bit of a flick,
Yeah.
probably a bit of a dodgy tap changer somewhere, not working quite the way it should.
Oh, okay. Yes.
Or they might dim down and then come back up again.
Yeah.
Sometimes they go right out.
Is that what they call brownout when that happens?
Brownout, no, well, brownout's usually when it gets a bit more dramatic. You know, I suffered a brownout at the airport in Manila, I think, one time. Everything just went out. Lights gradually went down, and then they went out. And somebody said, "Don't worry, wait. PA system came on. Wait, the lights will be back on again." Sure enough. Thank you.
Ron.
Peter, who were the last customers for the DC supply? I mean, obviously the tramways and the railways into DC, but who were the other people
No.
that were being supplied?
I can't answer that directly, but generally the answer is the railways and tramways had their own supply. In the city, the council supplied the tramways initially at 6.6 kV. The railways had their own network. Okay, so I think it's fair to say that they were private individuals. Now, some years ago, I was told that in the roof of the Comedy Theatre in Melbourne is a huge slow-speed DC motor for circulating the air, and it's impossible to get that out without removing the roof. So they were on DC, and I think probably they're still on DC, but they've got their own rectifier banks in there. There was a motor engineering place in Elizabeth Street where you could take your car for service, and I'm now talking early 70s, I think I saw that. They had an elevator that you just drove your car onto, and the car went up to the actual maintenance area a couple of stories further up in the building, and the building just looked like an office building.
Yeah,
So
DC was used for lifts.
yep,
like
all the
three
lifts,
buildings.
yes, but they gradually converted. As things failed, the council's policy was to go to AC, three-phase AC. So as systems failed or buildings did an upgrade, the council would be in consultation with their architects and engineers, and they would say, well, look, sorry, this DC is not going to be there forever. You know, start thinking about using AC. I've said enough.
Right, thanks very much, Peter. Thank you for a fascinating presentation. Not only has Peter collected all this information and researched it, but he's thought very hard about it and pieced it all together and connected all the bits and pieces, which is what a good historian does. So thank you very much, Peter. I was fascinated. And please accept from us a limited edition engraved glass from the RAOTC. Could you again show your appreciation?
Jim, sorry, I thank you so much, everybody. I appreciate that. There was something here I did want to show you, and I totally forgot. I'll pass it around. This is quite rare. Three-phase, paper insulated, wax impregnated, high voltage cable.
6.6.
No, possibly 11. The council, this is one thing I did miss out saying, the council decided early on that the growth of load was scaring them all the time. There was more and more power being demanded. So some of the smart thinkers early back decided that they should go for 11 kV cable, although they'll be operating it at 6.6. And this could be 11, I'm not sure, it's quite old, but there, if you notice it, each phase is made up of two segments, and the way that protection worked was that those two sections of each phase were balanced. So the system was looking for a balance in current flow between the outer and the inner. If there was an imbalance, there was leakage of some sort or a fault of some sort. So I'll pass that around as well. I'm sorry, that should have gone earlier. Thank you.